We're going to look at two more properties of exponents that we can now apply to our problems. Remember that these two new ones add in with the ones we've already got, so you're going to have more rules now that you can use. The first rule that we're going to consider is the power of a product. Now, a product is just any things that are multiplied together. So let's say that I have 2a squared, and I want to raise that to the fourth power. So let's think about what that would mean. If I raise something to the fourth power, that means I'm going to multiply it by itself 4 times. So that would be 2a squared times 2a squared times 2a squared times 2a squared. 4 of them all together. Okay, so what I want you to look at is how we could sort of break this down a little bit further. You see that I'm going to multiply by 2 4 times. So that would be the same thing as writing 2 to the fourth. And then I have a squared 4 times. So that would be like saying a squared to the fourth power. So we know what this one does. That would give us a to the 8th, and then 2 to the fourth is 16. So if you look at how we could get from here to here, hopefully you're kind of noticing that all we did to apply this fourth power to the product is we did the 2 to the fourth power separately and the a squared to the fourth power separately. So to do the power of a product, you just raise each factor to that product. So this one has 2 factors since it's 2 times a squared. 2 is a factor and a squared is the other factor. The second rule that we're going to look at today is going to be the power of a quotient. Remember, a quotient looks like division. So let's say that I have a over b, and I raise that to, let's say, the third power. Well, that would be a over b times a over b times a over b. Now, when we multiply fractions, remember we just multiply, whoops, I didn't mean to do that. We just multiply straight across. So I'm going to do a times a times a, and I'm going to do b times b times b. So my fraction ends up looking like a cubed over b cubed. So let's look at what we did here. When I wanted to do the cube of a over b, which looks like a fraction, all I did was apply that exponent to the numerator and apply that exponent to the denominator all separately. So that's all that we're going to do that's new today. So let's go ahead and look at some examples. Let's formalize our rule here. To find the power of a product, you're going to find the power of each factor and then multiply. So for example, if I had 2 times 3 to the fourth, then that would become 2 to the fourth times 3 to the fourth, which is 16 times 81, which gives me 1,296. So that would be your answer. Looking at algebra, I might have something like 4n squared to the third. Well, that would have to be 4 to the third times n squared to the third, and that would become 64n to the sixth. When you get good at these, you can start doing some of the steps in your head so that you don't have to write it all out. But for now, I would practice with all of it there. The second rule is the power of a quotient. So to find the power of a quotient, you want to find the power of the numerator and the power of the denominator separately, then divide. So for example, let's say that I had 3/5 and I wanted to raise that to the second power. Well, we would square each one separately. So 3 squared over 5 squared would give me 9 over 25. Then I want to check if that fraction can be reduced. This one can't, so that means that we're done. If I had something in fraction form, let's say that maybe I had 3 over x to the fourth. I would do 3 to the fourth over x to the fourth, And that would give me 81 over x to the 4th. You just do each one separately. Okay? I would suggest that you try to put this on pause right now and maybe try A, B, and C on your own. Then come back and check in with me after you've done that. So if we look at example A, this is the first rule because this is 1.5 or negative 1.5 times y. So this is one factor and a second factor. So that means that we're going to do negative 1.5 squared times y squared. Negative 1.5 squared is 2.25. And then we have the y squared, so that would be our answer. Okay, example B, this is a quotient. So we're going to do a to the third over negative 10 to the third, which becomes a to the third over negative 1,000. And that's your answer. Pretty simple. So moving forward now, this is combining some of the different rules. So if we look at example C, the quotient rule says that this would be 3d to the 4th over 2 to the 4th. But now the numerator here is an example of our product rule. So we would have to do 3 squared d squared over 2 to the 4th. Whoops, that should not be 24. That's 2 to the 4th. And so we get 9d squared over 16. 9 over 16 doesn't reduce, so you know that you're done. Example D is an example that has a negative exponent. It's very similar to C, except it's got a negative. So let's write it out the same way. We're going to do 2x to the negative 5th over 3 to the negative 5th. And we can go ahead and move stuff around now. So if we look at what this is going to turn into, this base is 2x. It's unhappy. So it wants to be moved. Once I move it, now it's happy. The 3 has a negative exponent. It's unhappy. It wants to be up here. Now what we have to do in the bottom is 2 to the 5th. And if you want to start skipping some steps now, you can. So 2 to the 5th gives us 32. And x to the 5th just gives us x to the 5th. So that's the answer. This next one, we have to do 10 to the negative 3. And then y to the negative 2 to the negative 3. Now look at what happens with that negative exponent. This 10 to the negative 3 is not going to change. But a negative times a negative makes a positive. So this is now y to the 6th. If we go through one base at a time, this one wants to move, but this one is good. So our final answer would be y to the 6th over 1,000 because that's what 10 to the 3rd is. And then the last one would be 1 to the 5th over 2k squared to the 5th. So this would be 1 over 2 to the 5th, which is 32.
Sam.
Sorry, we had an announcement. And then k squared to the 5th, power of a power. So we'll multiply those and we get k to the 10th.
With Justin Vochat.